All right, so graphs that have an x as the exponent are called exponential functions. Right, your hint to remember that is that it says x as the exponent. So if you take a look at this, y equals a times b to the power of x. Whenever you see that variable x in your exponent, that tells you it's going to be exponential. I think it's kind of easy to remember because your options are either exponential or logarithm. And so the exponential kind of just explains that. Exponential functions have a horizontal asymptote. Have you guys seen the word asymptote before? Okay, we'll talk about what an asymptote is. All right, so if b is greater than 1, or if the graph is going away from the asymptote, we call that a growth. But if your b is greater than 0 but less than 1, or if the graph is going towards the asymptote, we call that a decay.
How did you say it?
How do you say that? Decay? D-E-C-A-Y? Decay. So I like to use mnemonic devices a lot. My mnemonic device that I like to remember is that if it's going away, it is growing. I just think about the W's, 4 little words. So if your graph is going away from the asymptote, that's growth. If it's going towards, I like to think about the letter D in towards is also, and it's kind of cheesy, but that's just how I remember it. You guys can remember it however you want. But that just helps me out. Okay? I typically teach that you guys need to know how your graph is going, whether it's going away or towards. If you want to look to see if b is greater or b is less, that's possible, but sometimes it gets harder when we have numbers for a and b. You guys get confused on what to do when. All right, here's your example. There's an x in my exponent. Do you guys see that? So it is an exponential graph. All right, so what we're going to do is we are going to get some points. Let's say we want -1, 0, 1, 2, and 3. I'll show you both ways. If you have your TI calculator, I'll show you what you can do. You clear it out. You go to your y equals. Clear that out. You can type in exactly what your y equals is. It is 2 to the power of x. Okay? Because I'm just trying to get some points, we can hit second graph to get my graph here. You started at -1, right? So we will put in 0.5, 1, 2, 4, and 8. Does that make sense? How to get our numbers for our table? I just chose those points because it's easy to graph. I'm not going to graph 4, 16. That's going to be way off my grid. If you have Desmos, you can type in y is equal to 2. This little button here is your exponent button, and I like to just backspace and put in the letter x. That's what my graph looks like. If you hit this little flower, the edit button, then go to table, it gives you the same thing. I went to 3, so you can type that in. So you have -1, 0, 1, 2, and 3, and your same numbers. Okay, is that clear how we do it with TI and with Desmos? All right, so let's put those points in. It was -1 and 0.5, 0, 1, 1, 2, 2, 4, and 3, 8. Once you guys write that down, I want you to go ahead and graph it. So we have, I'm going to make my line bolder. I can never really see it. Okay, so -1.5 is in the middle. 0, 1, 1, 2. You guys see how it's gradually getting bigger? 2, 4, 1, 2, 4, and then 3, 8. All right, when you guys connect your dots, you guys see how we're basically starting up here, it's curving a little bit, and then it kind of flattens out. That's what my graph looks like. We're going to get to the whole asymptote thing soon. All right, so let's ask ourselves, from left to right, what is happening? From left to right, am I going away or towards my, actually I can't even ask you that yet. Hold on. I didn't go over this yet. Your asymptote is basically where the graph gets really, really close to, but it never touches. So my asymptote is here. Okay, you don't really know why, but I'll tell you that in the next slide, or the next 3 slides. So here's my asymptote. It's basically just a line on the graph that my graph gets really, really close to, but it doesn't touch. It looks like it's touching, but it's not. So if I go from left to right, am I going away or towards my asymptote? You're going away from it. So this would be growth or decay. This would be a growth. This is from SOL. What's this from? From Street to Truth. All right, I'll go example 1. All right, look at example 2. Are you guys using the calculator more or Desmos more? Raise your hand if you're doing the calculator to get your points. Raise your hand using Desmos to get your points. Okay. So let's do Desmos. All right, so for this one, we have y equals, and my equation is parentheses 1 divided by 3. Close parentheses, then x is your exponent. That's what my graph should look like. And I'm going to get some points from my table. And I like to add in, I normally start, oh yeah, this is fine. Start at -2. -2, -1, 0, 1, and 2. Once you have those points, write them into your table. Okay, once you guys have those points, then you can start plotting your points. That's -2, +9. -1, 3. 0, 1, when you get the decimals, guys, just try to estimate. I mean, 0.33 is going to be very close to 1, or sorry, to 0. 0.1 is basically on that same line. So here's my graph. Notice how I'm getting really, really, really close to that asymptote, but I'm not touching it. So here's my asymptote. My graph's a little off when I start to curve it, but if we go from left to right, am I going away or towards my asymptote? Am I going away from it or towards it? You're going towards it. So would it be growth or decay? Decay. All right, I want you guys to do examples 3 and 4 at the bottom of the page. You can assume that your asymptote is here and is here, because that's where it starts to flatten out at. So Sienna, from left to right, example 3. Away or towards?
Away.
Away, so growth or decay?
Growth.
Growth. That 4-letter word with the W's. Alright, what about example 4? Think on away or towards? You're going towards it, so growth or decay? Good. We understand growth and decay. Okay, good. Alright, so this part, you guys should be familiar with. It looks a little different, but we've done this before. If I look at my first, if I look at what's in front of that letter B, that A can tell me 3 things. What if that A is negative? What is my graph going to do? There's a negative out front. We did this last class. It's going to reflect. Good. So write that down. I also want you to write down exactly what I have up here with the minus sign in parentheses. What if that A is bigger than 1? Just a greater than sign. It's going to stretch. Good. And we have one more. What if it is less than 1? What is it going to do? Compress. So even though we haven't done exponentials before, you can still tell what your transformation is going to be because we've already learned it. We've already learned transformations of quadratics, of cubic, of linear graphs. So we should be good. All right, so the B here, we really haven't talked about that much, but just a little bit. If it is greater than 1, it's going to be a growth. If it is smaller than 1, it is going to be a decay. Let's set my sign here. Let's fix your sign on compressed. That should be if it's less than 1. So we will typically look at how we just did the growth and decay. We'll typically look at it and say, am I going towards the asymptote or away from it? If you want to look at your equation and see if you can tell what it is, that's fine, but I think that's kind of more confusing. Alright, look at this minus h. That's what we did before inside the parentheses. We went horizontally, so left to right. So what if I have a negative h? Would that be left or right? It's gonna be right. So if it's a positive h, you go to the left. You guys have to remember my mnemonic device for this too. I think about the plus sign and left. I can make a plus sign twice in the word left. That's just my reminder. Plus is left. Plus is left. And then we all should get the very last one. Plus k. What if it is a minus k? Which direction do I go, vertical, up or down? We go down. And if it's positive, we go up. Your domain for these graphs will always be all real numbers, negative, infinity, positive, infinity. Your range is going to be either from your asymptote up to infinity or from negative infinity to your asymptote. That's what that k is. And so your horizontal asymptote, I've already basically told you why. This horizontal is always y. And it's going to equal k. Whatever your last number is, that's what your horizontal asymptote is. So now that we know that, we'll know how to do these graphs. Any questions on this first part? You guys have these written down?
Almost. I don't have it.
Okay. All right, example 5. Notice how I don't have anything after my exponent, so I'm just going to put plus 0. My last number tells me what my horizontal asymptote is. So my horizontal asymptote is going to be what? What's my last number? 0. If there's nothing there, I have to assume that my asymptote is 0. I want you guys to create an asymptote by drawing a dotted line. And because it's y equals 0, you should have a horizontal line right at 0. That's your asymptote. All right, let's get some points. All right, so my equation is, so it's y equals, and we have, I'll put the 4 in parentheses. 4 times 2. I'm not sure if that supposed to be in parentheses or not. Actually, just put the 4 in parentheses, because that's being multiplied. To the power of, and then you can backspace it, x minus 3. It's a little difficult on Desmos. All right, so your exponent has to be in parentheses, because if not, it's going to look crazy. And then you don't have to put the plus 0. If I were you, I would start with 0, because you don't want to grab too many decimals. So let's start with 0, and let's go to 4. So 3 and 4. There we go. So on your paper, let's write 0, 1, 2, 3, 4. And then you can fill in these numbers for your y's. And while you're writing, I'm going to write them too. Make sure you guys are trying this on your own in Desmos, because by yourself, I want you to know how to do it. 0, 1, 2, 3, 4. And you can use whatever numbers you want, but I like to try to use as many clean numbers as possible. Alright, and then once you get that, go ahead and plot your points. Okay, sounds good. Thank you. Okay, this is your mom. You sign it and or your mom signs it. Alright, so we have 0 and then 0.5. Little 1, 1, 2, 2, 3, 4, 4, 8. Alright, I'm going to get really close to my asymptote. I'm never going to touch it. I'm going to try to connect the rest of my dots. As long as you're able to sketch this graph, you should be okay. Joanna, do I have a growth or do I have a decay? Growth, you guys agree? From left to right, I'm going away. So good, I have a growth. If you wanted to look at your equation to tell whether you had a growth or decay, you would look at this 2, because that's your B technically. Because it's greater than 1, you'll do growth. But I still think it's easier to look at your picture. My domain from left to right, I'm going on and on and on forever. Even though I'm going up, I'm still going wider. So that's going to be negative infinity to positive infinity. That will always, always be your domain for these graphs. Alright, so your range. You start from the bottom. If I start from the bottom, where am I starting? Where's my graph starting? What's my asymptote? What's my asymptote? So even though we graph 0.5, if I were to go higher, I would have points all the way lower, closer to my asymptote. I would just never actually touch it. Okay, so my range is from my asymptote, which is 0, and I go up to where? Infinity. Alright, my y-intercept is where I'm crossing the y-axis. Well, in this case, it tells me, because it says 0.5, but if you were in Desmos, look to where you cross the y-axis. You can click it, 0, 0.5. So that is your y-intercept. You can also write, if you want, I'm not really picky on this, you can write y equals 0.5. Either way works. If you don't want to put it as a point, that's fine. Just make sure that you're writing y equals for whatever your y value is. Any questions there? All right, let's look at number 6. I'll have to find my asymptote first based on my last number. What is my last number here? 3. So y equals 3. So let's go to where y is positive 3, which would be here. Go ahead and draw our asymptote. I'm going to make my lines darker up here because, as I told you guys, I can hardly see the origin. So whatever your asymptote is, right now our asymptote is at positive 3. So draw your dotted line at positive 3. I will be looking for you guys to know how to draw your asymptotes. Alright, so now let's go get some points. For this one, my points that I used were -3, -2, -1, 0. Let's see what we get. What is it, what?
It's not near the line.
What do you mean it's not near the line?
Like it's not on the...
Our asymptote was at positive 3. So it is near that. Your asymptote's not always going to be at 0. You know how we drew it here? That's the line it gets close to, because that's your asymptote. Does that make sense? All right, so let's type this in and get some points. So we have y equals 2 to the power of, and then do your parentheses. So put your exponent in parentheses. X plus 2, close parentheses. From here, you need to scroll over so it gets out of the exponent, and then do plus 3. So Joanna was saying it's not close to the line. Well, that's when our asymptote was at 0. Our asymptote now is at 3. You guys see how it gets really close to that positive 3?
Yeah.
That's how we can see what our asymptote is. All right, let's get some points. What did I say? Negative 3, negative 3, negative 2, and then negative 1, 0. All right, so I didn't even use these points down here. That didn't matter. All right, so those are the points I used. So let's go ahead and put them into our table. So I have 3.5, 4, 5. Normally what I do is I type in my equation, I look at my table, I try to pick like 4 to 5 points that are positive. If one's decimal, it's fine. I try to just find whole numbers. All right, plot our points. Negative 3, positive 3.5. 1, 2, 3. Negative 2, positive 4. 1, 2, 3, 4. Negative 1, 5. 1, 2, 3, 4, 5. And your points would make more sense than mine. 1, 2, 3, 4, 5, 6. Sometimes 4 is off. So it looks like this is my graph. Which way do I have a growth or do I have a decay? Growth. I'm going away from my asymptote. That is correct. All right, what's my domain?
Infinity sign.
Negative infinity to positive infinity. So I'm gonna write this down. All right, what's my range? Where does my graph start? At my asymptote, which is what? Positive 3, and I'm going up to what? 3 to infinity. My y-intercept is where I cross the y-axis. Is actually in my table. It will be 0, 7. All right, when you guys turn your table, what do you see? All right, so do you guys have, I think somehow my packet is wrong. Do you guys see this, number 7?
Yes.
Okay, in my packet I have the graphs. Does anybody have the graphs? So maybe I just did my packet wrong, which is okay with me. Okay. Huh? I know what comes next. Number 7 is first, right? Yeah, you're good. All right, let's do number 7. It says from y equals 2 to the power of x to y equals 2 to the power of x minus 2 plus 4. What is your transformation? Well, let's see. What are my transformations here? That negative 2 is new, and this guy is new. So I have 2 transformations. What's my first one? What does that minus 2 tell me to do? Right? How many? Yeah. All right, what does that plus 4 tell me to do? Up 4. If you guys are struggling with your transformations, make sure you go back and look at that page that we just did. It gets better with practice, but you gotta know your transformations. All right, number 8 says from y equals 3/4 to the power of x to y equals negative 3/4 to the power of x plus 1 minus 2. What are my transformations? So I have 1, 2, I have 3 transformations, right? You guys agree? That's the only thing different from first graph to the next one. Joanna, what's my first transformation?
Plus
Okay, we're gonna reflect.
left 1.
We're gonna go left 1. What's that negative 2 tell me to do?
Down 2.
Down 2. Okay. All right, we're gonna do 2 more problems together that are a little different. Desmos does this because I don't even know. All right, E. E is an irrational number. Which is approximately 2.718. We don't really need to know that because we have decimals and we have a calculator that can do it for us, but it's good to know. All right, let's look at our example number 9. All right, so when you have e to the power of x, and you have your ti, so y equals, to get to e, if I remember this, we do second ln, which is right beside 4. So if you go to second and then ln, that brings up your e, and then you would just type in x here. And then the second graph would give you a table. So the same way we've been doing. Not sure how many pretty numbers there are. Here I have all the decimals. Alright, so that's how you can do it on the calculator. If you have Desmos, we have y equals, let's see here, go to functions. I don't think the regular E will work, but let's see. Oh, it does work. All right, so in Desmos, just type in the regular E from your ABC. And then go to the exponent, backspace to make it an X. And there we go. My numbers that I used were -1, 0, 1, and 2. So we go to our graph. Yes. Yes. So go to our graph. I have -1, 0, 1, 2. That's just what I chose. You can do whatever you want. 7, 1, 2.7, and then 7.4. So you can always avoid decimals, especially when we have our E. So I'm looking for my my asymptote. Do I have anything behind my exponent? No, so it's basically plus 0. So where is my asymptote? 0. Your last number is your asymptote. Just draw a dotted line. Make sure you're drawing your dotted line. Now we can graph it. -1.37. I mean, some of these are going to be so small. Just try your best. Estimate 2, 1, 2, 3, 4, 5, 6, 7.4. Then we can connect our dots. Get really close to the asymptote. We can draw our graph. So Curtis, growth or decay? Let's go. Good. We're using growth. My domain is always going to be negative infinity to positive infinity. My range is from my asymptote, which is 0 up to infinity. My y-intercept, I'm crossing the y-axis here. At 0 1. Or you can write in y equals 1, either way. All right, so what I want you guys to do is I want you to work on the back. 11, 12, 13. Once you're done, come get it checked. You'll get classwork points based on you doing these 3. Once you're done, come get it checked, and I will check off exactly where you're getting it right or where you're getting it wrong. Okay, if you don't work in partners, that's fine too. Okay, Josh?
Yeah.